Okay, in this video I'm going to do problem 9, shown here. I might have time for problem 10 also, I think. Problem 9 says, how many possible permutations are there of the set containing these 7 shapes? Explain the reasoning behind your answer in detail. Well, the number of permutations is the number of rearrangements. You can also think of it as the number of bijections from the set onto itself. And we're going to count the number by using the counting principle. And the number is, well, what we're going to do is we're going to form a permutation or a rearrangement of those 7 objects in 7 steps. And we'll have, in the first step, 7 different objects to choose from. Now we're permuting them, so we can't choose the same one again, and so we only have 6 possibilities as choices for the second step. And then 5, 4, 3, 2, 1. And we know then that this is 7 factorial. I'm not even going to calculate the number. In general, the number of possible permutations of an n-element set set is n factorial. Okay? And so that one's quick and easy. I think I will have time to do number 10. And number 10 says, consider the set B made up of these 3 shapes, triangle, square, and circle. Write out all the subsets of B and show that the number of subsets obeys the general formula for the number of subsets of an n-element set. Let's do that first. For part A, all the subsets, let's see here. We have the empty set. You know what I can do? I'm going to go ahead and notate this as the power set of B. And it's going to be the set of all subsets. And so it's going to contain the empty set. It's going to contain all the singletons. The triangle by itself, single element of the square by itself, and the single element of the circle by itself. And then it's going to contain groups of 2, the triangle and the square and the circle, and the triangle and the circle. And finally, it's going to contain the 3-element subset, which is the entire set. And those are all the subsets of the element B, and that is called the power set of B. And the number of subsets is equal to 8. So the size of the power set of B is equal to 8. And why is that? Well, it's 2 raised to the size of B, which is 2 to the 3rd, because the size of the set B is 3. Okay? And why is that? Well, it's 2 to the 3rd, or 8, because we can count these by doing binary counting. We can say that the empty set is 0, 0, 0, meaning that none of the 3 elements are in it. The first 0 would signify the triangle, the second would signify the square, the third would signify the circle. 3 zeros means none of those 3 are in the set. The triangle, the next set could be considered as a 1, 0, 0, because it has the triangle, so there's a 1. It doesn't have the square, and it doesn't have the circle, so we have zeros. The square would be a 0, 1, 0. The circle would be a 0, 0, 1. Triangle and square would be 1, 1, 0. Square and circle would be 0, 1, 1. Triangle and circle would be 1, 0, 1. And finally, all 3 would be 1, 1, 1. And so you can see we have all the binary numbers 0, 0, 0, 0, 0, 1, 0, 1, 0. We're counting from 1 to 7 in binary. And there are 8 of them. Okay, from 0 to 2 to the n minus 1, where n is equal to 3. 0 to 7. Okay, Show that the number of subsets of B obeys the general formula for the number of subsets of an n-element set. Well, in general, the size of the power set of a set A is equal to 2 to the size of A, and that works out. So I think I've already sort of done part B there. In any case, the general formula is 2 raised to the size of the set, so that works here. Okay, let's move on to part C and D. How many 2-element subsets does B have? 2-element subsets, so here's, I guess, part B. Here's part C. How many 2-element subsets? Well, here they are. 1, 2, and 3. Number of 2-element subsets of B is equal to 3. And it doesn't ask us to write them all out. It just says how many. So I guess I'm done with part C. And part D says, show that this number obeys the general formula. So in general, we have the number of K element subsets of an n element set is equal to C n K, which is our number of combinations n factorial all over n minus k factorial and k factorial. Okay, and so if I take the case of n equals 3 and k equals 2, then I'm talking about 2-element subsets from a 3-element set. And C3 comma 2 is 3 factorial over 3 minus 2 factorial, 2 factorial, which is 3 times 2 times 1 all over 3 minus 2 is 1, so 1 factorial, 2 factorial, 1 times 2 times 1, which is 3. And I think I'll try to separate this off so it doesn't interfere with my other equal sign over here. Okay, and so that works. The number is 3, and that obeys the general formula. Okay, and just as a reminder, this is also equal to the third or fourth row down of Pascal's triangle. This is the n equals 0, n equals 1, n equals 2, and n equals 3 row of Pascal's triangle. And you can see here that this is the number of 0-element subsets, the number of 1-element subsets, the number of 2-element subsets, and the number of 3-element subsets of a 3-element set. 1, 3, 3, 1, and we can see that exactly up here. We have our 1, 3, 3, 1. And that's one of the rows in Pascal's triangle. And so that's the other fact about Pascal's triangle is if this row is giving the number of subsets of different sizes, if I sum them all up, then I'm going to have 2 to the third, or 8. 1 plus 3 plus 3 plus 1 is 8. Okay? So hopefully that helps on these two problems, numbers 9 and 10 here.